Betelgeuse's star, a crimson supergiant situated in the constellation Orion, has long intrigued astronomers and admirers of the sky due to its enormous size and luminosity. If Betelgeuse were positioned where our Sun is, it would stretch out to the orbit of Jupiter, a testament to its gigantic proportions. Despite being located approximately 642 light-years away from Earth, its vast size renders it one of the most luminous stars observable to the unaided eye. However, in recent times, Betelgeuse has demonstrated unusual behavior, such as unexpected dimming and brightening cycles, which, according to many researchers, indicate that the star is approaching the end of its existence. The esteemed physicist, Brian Cox, recently made a revolutionary announcement that Betelgeuse is on the brink of a catastrophic explosion, anticipated to occur within the next 2 weeks. This phenomenon, known as a supernova, will signify the conclusion of Betelgeuse's life, but will present an unprecedented chance for scientists to investigate one of the most extraordinary and powerful occurrences in the cosmos. As a giant, Betelgeuse is getting closer to exploding. Categorized as a red supergiant, one of the largest and most massive types of stars in the universe, it has been on the astronomical radar for centuries. But its recent erratic variations in brightness have sparked speculation that the star is preparing to go supernova. When a star like Betelgeuse reaches the end of its life cycle, its core collapses under its own gravity, leading to a colossal explosion that sends out an enormous quantity of energy, radiation, and stellar material into space. Betelgeuse's impending explosion is predicted to be a Type II supernova, a specific variety of stellar explosion that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that disintegrates the star. The detonation will be so brilliant that it could be visible from Earth without the requirement for telescopes, perhaps even outshining the moon in the night sky for weeks or months. While such an event would typically be disastrous if it occurred, near another star, Betelgeuse's distance from Earth, approximately 642 light-years, means that, although the explosion will be conspicuous and dramatic, it will not pose any threat to life on our planet. The event, however, promises to redefine our comprehension of supernovae and cosmic phenomena. A supernova is one of the most powerful occurrences in the universe, releasing more energy in a few seconds than the Sun will throughout its entire lifespan. Betelgeuse's explosion will not only be a spectacular celestial display, but also a significant moment for scientific inquiry. Researchers are eager to observe this rare event from its very onset, utilizing a variety of terrestrial and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much data as possible. When Betelgeuse detonates, it will emit a broad spectrum of radiation, from visible light to gamma rays. One of the most crucial components of the supernova will be the influx of neutrinos, elusive subatomic particles that rarely interact with matter. Supernova-derived neutrinos can actually reach Earth before the light from the explosion due to their ability to traverse nearly everything without being affected. Observatories like Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are getting ready to detect these neutrinos, offering a head start in observing Betelgeuse's final moments. Additionally, the explosion will provide vital insights into the formation of heavy elements. When stars explode, they forge and distribute elements like iron, gold, silver, and uranium, materials that are essential for life as we understand it. The study of Betelgeuse's supernova will offer real-time observations of this element creation process, which is essential for understanding the formation of planets and the universe's chemistry. Although Betelgeuse's supernova is not expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in intriguing ways. The energy burst from the explosion, especially the arrival of cosmic rays, and charged particles could create more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays could potentially disrupt satellite communications and some technology on Earth, the disturbances are anticipated to be minor and short-lived. One of the most thrilling aspects of Betelgeuse's explosion is that it will be observable to everyone on Earth, not just professional astronomers with sophisticated equipment. For weeks or even months, Betelgeuse is expected to be the brightest star in the night sky, perhaps even visible during the daytime. This spectacle will enthrall not only the scientific community, but also stargazers and the general public, igniting renewed interest in astronomy and the cosmos. Astronomers have long pondered the demise of Betelgeuse, but Brian Cox's recent statement adds an unprecedented sense of urgency. In the upcoming weeks, observatories worldwide are preparing to examine each phase of the supernova. Scientific data collected will be invaluable, potentially transforming our understanding of stellar evolution, core supernova, and the distribution of cosmic matter. Betelgeuse's supernova will allow scientists to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such explosions travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust between stars, astronomers will gain a clearer understanding of the scale of the universe. In particular, the event will provide a golden opportunity to investigate dark matter and how it might influence supernovae. Dark matter, the enigmatic substance that constitutes about 85% of the matter in the universe, doesn't emit or absorb light, making it challenging to detect. However, observing the way light and matter move around Betelgeuse after its explosion could yield indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also assist in our comprehension of the life cycle of stars, particularly the way massive stars contribute to the creation of the elements necessary for life. Supernovae are the primary cosmic events responsible for dispersing heavy elements throughout the universe, elements that ultimately form new stars, planets, and even life forms. By observing Betelgeuse, scientists will acquire invaluable data on how these elements are forged and distributed. The cultural significance of Betelgeuse's explosion is profound. For millennia, humans have looked to the stars for guidance, inspiration, and meaning. The disappearance of one of the most prominent stars in the night sky will prompt philosophical reflection on the ephemeral nature of the universe. Betelgeuse has been a constant presence in the constellation. Orion, for as long as humanity has, documented the stars, and its absence will serve as a powerful reminder of the transience of all things. In various cultures, such celestial events have been interpreted as omens or signs of cosmic change. Betelgeuse's explosion may inspire a blend of awe, fear, and wonder as individuals from all walks of life witness a star's death. This extraordinary occurrence is likely to rekindle interest in space exploration and the growing field of astronomy, fueling humanity's attempt to comprehend the universe. Amateur astronomers are already preparing for the event, as contemporary technology enables nearly anyone with a camera or telescope to witness and document the supernova. This accessibility to science will bring individuals together globally, all observing the same celestial event and recording it from their unique viewpoints. Betelgeuse's explosion is not merely a singular astronomical incident, but also a pivotal moment for future exploration. The insights gained from the supernova will influence how we investigate additional stars, particularly as we journey deeper into space with missions to different planets and stars. Grasping the life cycles of stars and the supernova's mechanics is crucial as humanity seeks to broaden its presence in the solar system and beyond. Furthermore, the explosion will reignite enthusiasm in the quest for extraterrestrial life. Supernovae play a vital role in dispersing the elements necessary for life, such as carbon and oxygen, throughout the universe. By examining Betelgeuse's explosion, scientists can acquire an improved understanding of how the building blocks of life might spread to other planetary systems and potentially spark life elsewhere in the cosmos. The forthcoming explosion of Betelgeuse is poised to be one of the most significant astronomical events of our era. Its supernova will yield a plethora of scientific data, enhance our comprehension of the universe, and captivate audiences worldwide. Although Betelgeuse's end will symbolize the demise of a massive star, it will also represent the ongoing cycle of creation and destruction that governs the universe. A reminder that from demise, new stars, planets, and even life can arise. As we brace for this historic event, the world will be gazing at the night sky, eagerly awaiting the moment when one of the universe's most potent forces bursts into view. For scientists and stargazers alike, Betelgeuse's final act will be nothing short of breathtaking. As Betelgeuse approaches the last stage of its life, one of the speculations that still intrigues is the possibilities related to its upcoming explosion, which presents an opportunity to illuminate some of the universe's greatest mysteries: dark matter and dark energy. These enigmatic forces are believed to constitute the majority of the universe's mass and energy, yet they remain poorly understood by scientists. There is growing speculation that supernovae, such as the one anticipated from Betelgeuse, could be the answer to unlocking some of these puzzles. Supernovae release an astonishing quantity of energy and radiation, and some researchers believe that these powerful forces might interact with dark matter in ways that we can observe and study. One fascinating hypothesis suggests that dark matter exists as weakly interacting massive particles, WIMPs. If WIMPs are real, their interaction with the energy produced by Betelgeuse's supernova could provide information about their nature. Such an interaction would represent a groundbreaking discovery, offering the first direct evidence of dark matter, a phenomenon that has eluded scientists for decades. Additionally, there is potential for Betelgeuse's explosion to clarify the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. By analyzing the behavior of light and energy from the supernova, scientists might collect critical information regarding how cosmic events impact the universe's expansion and how they may relate to dark energy. Such findings could reshape contemporary cosmology and expand our comprehension of the space-time fabric itself. The forthcoming explosion of Betelgeuse also offers a unique perspective through which to examine the life cycle of massive stars, which are crucial to the cosmic ecosystem. Red supergiants like Betelgeuse are rare in the universe, making their study vital for understanding stellar evolution. These stars form from massive clouds of gas and dust that collapse under gravitational forces, eventually igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they expand significantly, shedding their outer layers through a series of powerful stellar winds. This mass loss enriches the interstellar medium, paving the way for new star formation. When Betelgeuse goes supernova, it will not only illuminate its own life cycle, but also serve as a cosmic laboratory for studying the conditions under which stars exist and perish. Researchers will diligently observe the aftermath of the explosion, where a neutron star or black hole may form at the core. The nature of this remnant will provide invaluable insights into the physical processes governing the final stages of stellar evolution. The dynamics of the explosion itself will also yield a wealth of information. The shock wave generated by the supernova will sweep through the surrounding gas and dust, heating it and causing it to glow brightly. This illumination will give astronomers clues about the elements produced during the explosion, including iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists can ascertain their abundance and distribution, which improves our understanding of how they propagate through space and contribute to the formation of future stars and planetary systems. Another exciting area of interest is the potential for detecting gravitational waves. As the core collapses and the supernova unfolds, it may generate ripples in space-time that can be detected by observatories such as LIGO and Virgo. Gravitational waves carry information regarding the underlying dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also be a driving force for technological advancements in astronomy. The anticipated influx of observational data will likely push the boundaries of current astronomical instruments. This event may lead to innovations in imaging technology, data processing, and real-time analysis, advancements that could benefit a wide range of astrophysical studies beyond just the supernova.